Almost 10 years ago, I was in a place where nothing seemed to make sense and my intuition failed me. One day, I made a small piece of ice and I dropped it into a very large scalding bath. And I saw this piece of ice melt and then recrystallize somewhere else, and then melt again, and then recrystallize where it was originally, and do this over and over for a few minutes. That did not make sense. This is not the world that I was used to. Now, there are some things that I need to come forward with about this story. This mysterious place is actually a place that you can walk to from here. It was the sub basement of one of the physics buildings at Harvard University. It was a windowless room where I got to basically live for 7 years as a PhD student. And this ice is nothing like what you're used to. It was a few tens of atoms that I controlled with lasers. And this bath is nothing like what you're used to. It was also just a laser. But the confusion, the awe, and the excitement of seeing this process happens was just as real as the picture that you were forming in your mind. Now, this can only happen in the quantum world. The quantum world is a world of extremes. It's the world of the very small, the very cold, the very massive, the very hot. It's also the world we live in. It's the only world that exists. But what I described is completely, entirely against your intuition of what would happen. So why is that? Why is it that we do not experience this quantum world? The answer to this is that many of these effects that we're not used to are very fragile. So we interact with the world every single moment of our lives, and we are continuously creating a picture in our mind about how the world works, what is possible, and what are the rules of the world. Well, it just so happens to be that the rules are much more complex than we think, and they're just hidden from us by this fragility. This is something that is pretty hard to believe. The quantum world is weird. Things are not well defined. And this is something that bothered even the people that made these discoveries. In 1952, Erwin Schrödinger, famous for proposing to put cats in boxes and do things with them that most pet owners would not agree to, said that this quantum world was ridiculous. The math made sense on averages, but the specifics of the quantum world were ridiculous. And specifically, he said in a 1952 article that he wrote, we never experiment with just one electron or atom or small molecule. In thought experiments, we sometimes assume that we do. This invariably entails ridiculous consequences. But with the benefit of hindsight, I can ask, what if? What if Schrödinger was wrong? What if we take these rules of this new science seriously? What if the science is right and this new science describes new rules and these new rules give us new possibilities? What if we can take these new possibilities and turn them into new technology? Technology, after all, is the vehicle by which we take human intellect and we use it to harness nature to expand our capabilities. If we take these ideas seriously and we say, let's assume for a second that the quantum world is a perfect description or the best description we have of reality, what could we build? Well, we could build sensors that are much more accurate than anything that we have seen so far. We can build communication systems that allow us to communicate without anyone ever being able to spy on us. And it would allow us to build computers that have power that we can't even start to imagine. Today, we live in a world that is defined by our technology and the fact that this technology is advancing at an ever-increased pace. We see this particularly in the world of computation. Over the last few decades, we have seen computation from the hardware grow exponentially. We know about Moore's law. And today, we see artificial intelligence change the world in real time. We are able to do things that we never thought about. But all of this computational power, all of this technology is based on the same set of rules that we have always had. Another way of saying this is that the data centers and supercomputers that are running these AI models are just a more advanced version of my laptop. And my laptop is just a more advanced version of a pocket calculator. But they all follow the same rules. Now, if we were able to build a computer that follows these different rules from the quantum world, we would be able to do so much more. The change would be unlike anything we have seen in history. I imagine if we can build one of these computers, we can accelerate the discovery of new materials for better information processing, for better energy transmission. We could accelerate the pace at which we find new life-saving drugs, and we could accelerate how we find new ways to create chemical products that are more efficient and better for the environment. I also imagine we would be able to take artificial intelligence to heights that we haven't started even imagining yet. Some of this would be accelerated in an exponential way, which is very hard for the human mind to grasp. But this all sounds very speculative. If we could build a machine, and this is a question that is not new. As a matter of fact, already 40 years ago, we had famous physicist Richard Feynman, who was particularly good at taking complex topics and simplifying them to their core, to their essence. And he was struggling with the idea of what would a quantum computer look like. And he said, now we can, in principle, make a computing device in which the numbers are represented by a row of atoms with each atom in either of the two states. The ones move around, the zeros move around. Finally, along a particular bunch of atoms, ones and zeros occur that represent the answer. Nothing could be made smaller. Nothing could be made more elegant. But can we do it? And that is the question that has remained with us. Can we do it? Well, since then, there have been many people that have tried to approach this problem. Can we actually preserve this quantum weirdness and harness it to do computation? And there are many different approaches today for how we think we could get there. We could use light, we could use electrons and little superconducting circuits. I want to show you today a picture. This is a picture where each one of these purple little spots that you're seeing is an individual atom that is being held in suspension in vacuum using a tightly focused laser. These 42 atoms were imaged in another mystical, magical place that is walking distance from here. This was done at QueRa Computing. And using technology that we have developed over the last 10 years or so, the same type of technology that led to my eyes that melted and reappeared and melted and reappeared, we are able to control every single property of every atom. The thing that Schrödinger thought we would not be able to do. And we can control how they move, how they interact with one another, and we can take the fundamental unit of matter of the atom and turn it into the fundamental unit of computation of a quantum bit. What you're seeing here is a video that shows how these atoms can be used as quantum bits to perform a computation. Namely, this is a quantum computer. Now, quantum computers are in their very early days, and the power of this is not what you would expect to train a large language model, but progress has happened incredibly fast. Quantum computers as a technology are advancing as fast as artificial intelligence. It's just happening in the background, and it's happening at a much earlier stage. Today, we have a small community that is trying to create an industry, all of us driven by this idea of how will we be able to change the world by increasing computational power and allow us to do things that we have never been able to do? I want to leave you with a few thoughts. First, sometimes to make radical change, we need to embrace what's different. Second, to make big leaps, sometimes we need to start small, sometimes as small as a single atom. Third, we need to redefine what's possible. We thought that controlling individual atoms would not be possible, yet we are doing it today. We are doing it at a scale that is increasing faster and faster every day. Putting all of these things together and all of these people together, we now have the ability to think of how to leverage technology in a way that allows us to, for the first time, think of computation in a different way, with a different set of rules. And this has the power to change the world. I see a future where quantum computers will improve the lives of everyone around the world, and I am looking forward to being joined by many of you to accomplish this together. Thank you.